Guys, I'm sorry we were out of our smartboard broke yesterday. We don't have that taped, but we're going to go over converting between degrees and radians. So here's my deal. I was thinking on my way over here that the definition I gave you for radians was right yesterday, but I got a better version of it today. Basically what takes place is this. A degree measure has no length. A degree measure just measures the size of an opening, and often it's kind of useful to know like the length of the size of the opening. You know what I mean? Okay? So here's what we're going to do. Degree measures just tell you how big an opening is, but a radian measure gives you a length for it. And how do you do that? Well, do you remember yesterday we talked about something called the unit circle? Tell me some things you remember. Good. And where is it centered? So it's a circle with a radius of 1 and centered at the origin. And from this day forward, anytime I refer to a circle, I'm pretty much referring to the unit circle, okay? So now tell me, what is circumference? What does it mean? Oh, we can't use thingy around the circle. Okay. Distance around? I'm going to give you a fancy word. Yeah, it's like the perimeter of a circle. Okay. So now, what is the perimeter? What is the circumference of the unit circle? Ooh, that's the problem. 360 is a degree amount. That just tells us how wide an angle is. But the length around it, right? The length around it, the circumference is 2 pi. Is 2 pi. Right? Circumference equals pi times diameter. You with me on this? Diameter was 2. Yeah, cherry pies are delicious if you wanted to remember it that way. So here's what I'm saying to you. A radian measure is how much of the circumference the angle is open to. You feel me on this? So what I'm saying is let's take a look at an easy question, right? If you have 180 degrees, how much is that angle open to of the circle? It's open to half the circle. And what was the circumference of half the circle? The circumference of half the circle. What's the circumference of the whole circle? No, you're not listening. Whoa. Yes, circumference is 2 pi. So what's the circumference of half the circle? Pi. So another way to describe this angle, instead of using degrees, is to say that it is about pi radians big. In other words, it is open to half the circle. Yeah, radians is just the name of the unit. Do you get what I'm saying here? A little bit? That's it. That's the only idea we're talking about today. We're going to do that for like 47 minutes. I know, that's going to be real boring. But on a scale of 1 to 10 in terms of importance, this ranks as a 10. Because what takes place is, next week, I'm going to show you things given in radians, and then I'm going to go show you things given in degrees, and you will have to be able to convert back and forth. Like, for me personally, I'm not so good with degrees. I don't even like really looking at them. So anytime somebody gives me a problem in radians, guess what I do with it? I make it into degrees because I'm not so good at radians. I'm sorry. I'm not so good at radians. So anytime they give me a problem given in radians, I take that and I convert it to degrees and I solve it, and then I convert that answer back. You got it? You good? Let's do this. So here we go. It turns out there's a formula for converting from degrees to radians. It's really easy, really easy. I drew a picture of what 45 degrees looks like on the circle. And if you had to say how much of the circle, how much of half the circle does 45 degrees cover? How many of those slices could we fit on half the circle? Like 4. Like 4. And what's the circumference of half the circle? So if you had to describe this angle in terms of the amount of circumference it opens to, what would you say it is? It's a fourth of pi, Lou. Good job, buddy. But some people are not so good at thinking like that, so we're going to show them how to use the formula. Okay, so let's do this. We got 45 degrees. Oh, come on, computer. Come on, work with me here. We got 45 degrees, and the formula is always the same no matter how big the degrees get. 45 times pi over 180 equals, well, that's just 45 pi over 180. And then what I want you to do is, yeah, just reduce that using your calculator. You know what I'm saying? Type in, you don't add pi on the end. You just reduce those two numbers. So what does that reduce down to being, Cam? What? It's a quarter. Good. So this is just 1 pi over 4. That's the answer. That's it. That's all you got to do. You could do 1 pi over 4, or you could say pi over 4 as you'll most commonly see it, or you could say 0.25 pi, but it's unlikely you'll ever see it written that way. And since you guys want to examine every single possibility, you know, go. Okay, let's play again. Suppose you have 90 degrees. How would you write that in radian measure? Half of pi, exactly. But if you're not so good at thinking about that in your head, all you have to do is do 90 times pi over 180. And that's 90 pi over 180, which is just pi over 2. That's it. Because 0.5 is how much as a fraction. But it's more important that you understand what a decimal form of a fraction is. If you saw like 0.6 repeating, what's that in fractional form? Sure. You will need to absolutely 100% become comfortable doing this in your calculator. Like, for example, take 30 degrees. We're going to convert this into a radian measure. So that's 30 times pi over 180. What's up? Ooh, you better be real careful about how you say it. 6 pi is absolutely gigantic. It's pi over 6. Because 30 divided by 180 is a sixth. And so we get pi over 6. Or 1 pi over 6, that's cool. No. This is as hard as it gets for today. Wait, but hear me out on this. Hear me out on this. If you get good at using your calculator, this trigonometry is no problem whatsoever. But if you don't understand the symbols or how to move back and forth, you will think this is absolutely the most ridiculous, hardest thing you've ever seen in your life, and it looks like some foreign language. You know what I mean? So let's do this. Let's do this. 160. Yep. 160 times pi over 180, right? That's 160 pi over 180. 8 pi over 9. Do you guys understand what this means? Felice, what about you? Do you understand what that really means now or not so sure? Yeah, let me show you. Let me show you. Just to give you a visual picture of what it is that we're looking at here. 160 degrees. Let's see if I can draw it in. I might have enough room right over here, right? 160 degrees. Here's my circle. You down with that? Now 160 drops me off in which quadrant? Drops me off in the second quadrant. Let me draw it in. Let's just say it drops me off right there. You get that? And so here's my angle. This right here is 160 degrees. See that? So look at how much of the circumference it is open to. How much is half the circumference of the circle? Pi. And so it's a little less than 1 pi. In other words, it's open to 8 pi over 9 of the circumference. That's it. That's all it is. Okay, that's what we're going to do next. So what's up? 220 times pi over 180. $220 pi over 180, which becomes what? 11 pi over 9. Yeah, just put it in the calculator. Okay, Gigi. Now, because this is what a lot of people want to know. Tell me what you want to do. What do you want to do with? It doesn't mean the same thing in this particular instance. Okay, so don't convert pi into 3.14, right? Because what we're trying to do is we're moving back and forth between how open an angle measurement is and how much of that relates to the circumference. Okay? If you want to try and sub in something for pi, here's what you do. In order to convert back from a radian measure into a degree, pi stands for 180 degrees because half the circumference is pi and half the circle is 180. So what you do is, if you're given a radian measure, you just sub in 180. 2 times 180 is how much? It's 360. And that's how to move back and forth between a radian measure and a degree measure. For me, since I don't like really dealing with things in radians, and that's just my own personal preference, pretty much anytime I'm given a problem in radians, I sub 180 in for pi, convert it to degrees, solve it, and then take my answer and convert it back to radians. Let's do this. 3 times 180 divided by 4. How much is that? Finally, let's do one more. 5 times 180 divided by 4 is how much? Okay, so you get the point, right?